Okay, how do the different sensors work? Again, now we're going to talk about those cones and the parabolic dishes. So cones, the listening cones, listen cylindrically, right? So if you think about a cylinder, right, or like the shape of a drum, it's looking longitudinally out that cylinder. And so there's a diameter is the cone mouth. So if the cone is maybe 3 or 4 inches around, it's that cone going forward is wherever you aim that cone, that's where the sound is going to be coming from. It's much more directional. And because of that, you typically get about a 15 decibel or a 5-time increase in the sensitivity that reaches the sensor. With parabolic dishes, they're even a little bit more precise. That's why they tend to have a laser pointer, so that as the parabolic dish is looking downrange, it's all of the sound is being gathered from that parabolic dish. As you can see, when the sound comes in, it bounces off the parabolic dish and comes into where the sensor is located. So everything along these straight lines is where the sound is coming in. And you can see on these dashed lines, the one coming in from the top, for instance, when it comes in from outside of that that path directly in front of the parabolic dish, it hits the back of the dish and reflects off at a different angle, an angle that's not going to impact on the sensor. So that's why parabolic dishes work a lot better at distance, because you can typically pick up about a 26 decibel amplification or 20 times the sensitivity. And you're actually listening to a point in the distance, not even a cone or a cylinder, right? You're listening to a specific point. So how far away can you be? If you imagine the sound source being something on the order of 30 decibel microvolts, measured at 1 meter with a standard airborne sensor. So that's the test setup that we're using. With the inverse distance law, remember that we add 12 decibel amplification for a cone, which would increase the distance 4 times, and 24 decibel amplification from a dish, parabolic dish, and that would increase the distance by about 16 times. So if we want to increase the signal by 30 decibels, we can increase the distance by up to 32 times, or it could be 2 kilometers. So if we think about the inverse distance rule, if we look at the decibel value being 30 and the distance being 1 meter, if we increase the distance, so the sound source remains the same, but we increase the distance from 1 meter to 2 meters, we lose 6 decibels in sound value. If we double it again from 2 meters to 4 meters, we get 18 decibels, or 12 decibels less than the 1 meter, and so on. And you can see how that inverse distance rule works.